we're going to be reviewing the last bit of term 1. So term 1, unit 3 was all about triangles. Now, unfortunately, there is a typo on this proof. Our proof triangle ABC should actually be proof triangle ABD. So, let's start our proof. First statement says B is the midpoint of AE. So, given. Now, in that vocab, or in that problem, we have a vocab word. Vocab word is midpoint. So I know my next reason is definition of midpoint. Midpoint is just like bisect. It splits a segment in half. So it says B splits AE in half. So I know that AB is congruent with EB. And I'll mark it on my diagram. Three, well, we have a next given. B is midpoint of CD. Once again, vocab word. So I know it's going to be definition of midpoint. So B splits CD in half. So CB, as I write AD, CB is congruent with DB. And once again, I'll mark it on the diagram. So we need 3 congruency statements to say the triangles are congruent. So I'm going to go through my triangle look for list. The first question was, does it look like a bow tie? In this case, it does. So I know I have vertical angles, which are the center of my bow tie. So I know angle ABD is congruent with angle EBC because vertical angles. We have 3 congruency statements. So I can say triangle ABD congruent with triangle EBC. Looking at my diagram, we have more sides marked congruent, so it's either side, 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 or side, angle, side. In this case, we have an angle between our 2 sides, so it's side, angle, side. For number 2, our given says the diagram. And what that means is look at the diagram, see what is marked congruent. For example, EB is marked congruent with CB. Because of those marks. Also, angle A is marked congruent with angle D. They have those arcs. So then going through our triangle look for list, first question, does it look like a bow tie? In this case, it does. So I can say angle ABE is congruent with angle DBC because they are vertical angles. And I'll mark it. Since we already have one arc, let's do double. We have three congruency statements, so I can say triangle ABE congruent with triangle DBC. And we have more angles marked congruent than sides. Now the trick to figure out if it's side angle or angle side is if we go from one angle that's marked congruent and drag our writing utensil to the other, we did not cross the side that is marked congruent, so this has to be angle side. Number 3 is a given the diagram problem again. So we're going to look at the diagram and see what is marked congruent. For example, AB is marked congruent with CD. Also, BC is marked congruent with DA. So we're going to go through our triangle look for list. First question was, does it look like a bow tie? It does not. So second question, do they share a side? In this case, they do. So because they share a side, I know that means it's reflexive. Property of congruence. And the side that they share is CA. So CA is congruent to CA. Well, we have three statements that are congruent. So I can say triangle BAC is congruent to triangle DCA. Because, well, we have more sides marked congruent. In fact, just side, so side, side, side. So we're always going to assume that we're proving the triangles are congruent. Always assume we're just doing that. Then check your proof statement to see if we have to go farther. Well, in this case, we do. So I know because I have to go one step farther, my reason has to be CPCTC. Or corresponding parts of congruent triangles are congruent. So I can say angle BAC is congruent with angle DCA. Number 4, write a congruent statement and list all corresponding parts. Congruent statement is saying triangle something is congruent to triangle something. So that is a congruent statement. All corresponding parts is listing all angles that are congruent and all sides that are congruent. So let's deal with the corresponding parts first. So I know angle S has one arc, matches with angle B. I know angle R has 2 marks, and that matches with angle C. I know angle T has 3 marks and matches with angle A. So there's our angles, sides. I know SR matches with BC. I know RT matches with CA. And I know TS matches with AB. So we have our three sides, we have our three angles. We need to say our congruence statement. So triangle SRT is congruent to triangle BCA. Now in part B, we have this congruence statement. I know Q matches with W. I know R matches with X. And I know S matches with Y. So first one says SR. So SR matches with YX. Angle R, so R matches with angle X. But perpendicular bisector theorem. So we cannot use the perpendicular bisector theorem in its own proof, but that is A-okay. So we'll start off with our first given like how we always do. Segment CD is the perpendicular bisector of segment AB. Now, in that given, we actually have two vocab words. The first vocab word stated is perpendicular, so might as well deal with that one first. So I know my reason is going to be definition of perpendicular. Perpendicular means two lines or line segments that make a right angle. So I know angle AC, as Mr. Johnson can't letter apparently today, angle ADC and angle BDC are right angles. So we have two right angles. Since we stated two right angles, I can say angle ADC is congruent to angle BDC. And because they are both right angles, that is a right angle congruence. Because all right angles are 90 degrees. So I will even mark that on our diagram. They're right angles and they are congruent. So we had one other vocab word, bisector. So for my reason for, I want to say definition of bisect. And bisect splits in half. So it says CD is splitting AB in half. So AD is congruent to BD. And I'll mark it. So we dealt with the vocab from our given. Let's look at our triangle look for list. First question, does it look like a bow tie? Does not in this case. So, second question, do they share a side? They do, so that means we have reflexive property of congruence. So the side they share is CD, so I know CD is congruent to CD. We have three parts of the triangle marked congruent. So I can say triangle ADC is congruent to triangle BDC. We have two sides marked congruent, so that has to be side, angle, side. So like I said before, always assume we're just proving triangles congruent, then check your proof statement. Our proof statement not only goes farther, but it has it equal. Well, I don't know how to go from saying triangles are congruent to an equal. I know how to go from triangles congruent to a congruent because of CP/CTC. So I can say then segment CA is congruent to segment CB. Now I do know, though, how to go from a congruent statement to an equals. So CA equals CB, because that's the definition of congruence. And 6, prove the base angle theorem. So we cannot use it in its own proof, but we have two given statements. So let's write down our first one. Segment KB bisects segment AC. That has a vocab word in it, so I know my next reason is definition of that vocab word. So definition of bisect in this case. Bisect once again splits in half, so I know KB splits AC in half, thus AB is congruent with CB. And I'll mark it. So then statement 3, we have a second given, AK is congruent with CK. And once again, congruent statement, so I'll mark it. Out of givens, so triangle look for a list. First question, does it look like a bow tie? Nope. They share a side though. So that is our reflexive property of congruence, meaning KB is congruent with KB. So we have three parts of the triangle marked congruent, so I can say triangle ABK that's congruent with triangle CBK. We have more sides marked congruent, so this is actually side, side, side. So check our proof statement. Do we need to go farther? In this case, we do. So I know my next reason has to be CP/CTC. And unlike in the last problem, our proof statement is a congruent statement, so we can just say angle A is congruent with angle C. Seven, find the value of x and find the measure of each angle. Well, I know all interior angles of a triangle add to 180. So I know that x plus 8x plus 90, that box, equals 180. Combine like terms, so 9x plus 90 equals 180. Subtract 90 from both sides, so 9x equals 90. Divide by 9, x equals 10. But then it says find the measure of each angle. So I know this angle here is x, so this is 10 degrees. Angle here is 8x, or 80 degrees. And that angle has to be 90 degrees. B, This is our exterior angle theorem. I know the two far interior add to equal our exterior. So in this problem, I know 2x plus 76 equals 5x minus 2. Subtract 2x from both sides. 76 equals 3x minus 2. Add 2 to both sides. 78 equals 3x. Divide both sides by 3. X equals 26. Then once again, we need to plug it into the angles. So once again, I know the 76. This is 2 times 26, or 52 degrees. I know for the 5x minus 2, so 5 times 26 minus 2, or we could do the 52 plus 76 to get 128. Meaning the angle in here would be supplementary. So we can do 180 minus 128 to get 52 degrees. Eight. This is our mid-segment theorem. It says points A, B, and C are midpoints of the sides. So I'm going to mark that on there. They bisect. So each of these halves have to be congruent to each other. It also says SR, going from S all the way to R, is 5x plus 4. And CA is 3x minus 1. Now the relationship for midsegments was our midsegment is parallel to the other side, and the length, so CA, has to equal 1/2 of the other side, so SR. So using that, we can actually write an equation. So I know CA is 3x plus 1. It's equal to 1/2 of the full length, so 5x plus 4. So solving, we distribute. So 3x plus 1 equals 2.5x plus 2. Subtract 2.5x from both sides. So I get 0.5x plus 1 equal to 2. Minus 1 from both sides. 0.5x equals 1. As Mr. Johnson realized that he messed up the equation. Actually, it's supposed to be minus, not plus. So we're going to add 1 to both sides to get 3. And we're going to divide both sides by 0.5, or times both sides by 2. X equals 6. So we know that CA is equal to half of SR, which in other words, then CA is the same length as SB. So what I'm going to do, SB is equal to the 3 times our X minus 1. So 3 times 6 is 18, minus 1 is 17. Now you could have plugged the 6 into the SR, the 5 times x plus 4, or 5 times 6 plus 4 gets you 34. And then divide that answer by 2 to get the half. Nine, prove DE is the mid-segment of a triangle ABC. So there are two things that we need to show on this. We need to show DE is parallel to AB, and DE is half of the length of AB. So, parallel, meaning we need slope. So going from, let's find DE first. We have no rise, so it's going to be 0, over, and we go over. Be careful. On our x-axis, if you notice, we're counting by 2's. So what may look like we're only going over 2, we're actually going over 4. So DE equals 0 over 4, or just 0. For AB, we have no rise. We're not moving up or down, so it's 0 over. And we're going over 8, or just 0. So we can say then, segment DE and segment AB have the same slope. So DE has to be parallel with AB. So the first part is proven. We show that they have the same slope. So they're parallel. Now for the lengths. I know then for DE, the length is, well, we can just count, is 4. Same thing with AB. I can just count. I can count over 8. So 4 is half of 8, so I can say DE equals 1/2 of AB. Given AC is 6 and AF is 3, so AC, the full length, is 6 and AC is 3. Prove segment BF is a median. So this is not going to be a math proof or a two-column proof. This is going to be a paragraph proof. And remember, paragraph proof is just using sentences to state it. So we can say, since AF equals 3 and AC equals 6, F is a midpoint. Now, there were two things about a median. Has to have one point be a midpoint, and the other one being a vertex, and it also has to go through our centroid. So, the other thing that we can say is, since DC and GA are medians, point at where they cross. Is the centroid. Finally, we can say since segment BF crosses the midpoint, or crosses the centroid, and is on the vertex and a median, midpoint, segment BF has to be a median. Now we have one last proof to look at. The interior angles of the sum of a triangle sums to 180. We have a given statement, triangle ABC, with line AD parallel to BC. So since we said parallel, we're going to look for transversals. Well, the first transversal I see right there, the two angles that form a relationship with that would be angles 1 and 4. So angle 1 is congruent to angle 4. Because that is alternate interior angles. Now, looking slightly ahead, I know in my proof statement we have to have equals. So I'm going to change this to be an equals then. So the measure of angle 1 equals the measure of angle 4. Definition of congruent. Now we do have another transversal, that blue one. So we can do the same thing. I can say angle 2 is congruent with angle 5 because of alternate interior angles. But then once again, I need to get it down into an equal statement. So I can say measure of angle 2 equals measure of angle 5. Definition of congruent. Now, also looking, I can see that angle 4, 3, and 5 make up a line. Now, typically we only deal with 2 angles that are supplementary. But supplementary just means angles in general that add to 180. So I can say the measure of angle 4 plus the measure of angle 5 plus the measure of angle 3 equals 180. all three of them add 180 because all three of them are supplementary angles. Now there's a chunk to plug in. We have measure of angle 4, measure of angle 4. So we're going to replace that with measure of angle 1. And measure of angle 5, measure of angle 5. We can replace that with measure of angle 2 plus measure of angle 3 equals 180. When we plug things in, that is our substitution property of equality.